مساء الخير، أهلا بكم طالبات وطلاب جريد 1 بريب. برحب بكم في حلقة ماث جديدة تحت رعاية وإشراف وزارة التربية والتعليم. النهاردة درسنا هيكون عن Polygons والmost common types of Polygons و how can we get the interior angle and exterior angle for any polygon. So let's get started. Our lesson is polygons, so let's get started with warming up. Already we know the sum of angles of any triangle is always 180. We studied that before and we need it today. So here we have. Let's talk about the definition of a polygon. Okay, it is a plane figure with 3 or more sides. So what does it mean? Plane, it means surface, like the paper surface. It doesn't have a height, so it is a plane, okay? Figure with 3 or more sides. Okay, can I make a polygon with 2 sides? No, of course. 2 sides not enough to make a polygon. So 3 sides or more. And also we have another definition here. It is simple closed line formed from union of line segments. So here we have closed figure, plane figure, and each side is line segment. Not allowed to make curve, not allowed to keep it opened, not allowed to make it with height. So it is a plane, closed figures with line segments. Let's talk now about the most common types of polygons. Number 1, triangle. And as we know, the triangle has 3 sides. Second, quadrilateral. Quadrilateral means 4 sides. So I have 4 sides. It can be square, rectangle, trapezoid, and so on. So, number 3, pentagon. Pentagon, it has 5 sides. Let's count them here. 1, 2, 3, 4, 5 sides. Then, number 4, hexagon. From its name and letter X, hexagon is, or it has 6 sides. Okay, keep that in mind. Octagon, it has 8 sides. Also, you can count them 1, 2, 3, 4, 5, 6, 7, 8. Then, number 6, decagon, it has 10 sides. So, these are the most common types of polygons. Now, we have another definition about convex polygon. What does it mean? In the convex polygon, any straight line determined by 2 consecutive vertices and the remaining vertices are on one side of this line. And keep in mind the convex polygon, each angle is less than 180. Okay. Here we have a pentagon. How do we know? Because it has 5 sides. 1, 2, 3, 4, 5 sides. And here we have side, then vertex. Here we have, this is the vertex. Okay. Then interior angle, it is inside the figure. Then we have exterior angle, it is outside, between the extent of side and the next side. So I have 4 things. Side, vertex, it is a corner, and interior angle, from its name interior, that means it is inside the figure, and exterior, it is outside the figure, between the extent of a side and the next one. Then the concave polygon. The concave polygon, there are straight lines determined by 2 consecutive vertices, and the remaining vertices are on the 2 sides of this line. And here the concave, it must, or it has at least one interior angle greater than 180. So the interior angle, one of them is greater than 180. Do you remember 180 is called what? Straight angle. More than 180 is called reflex angle. So here we have more than this corner, or this or this angle is more than 180, so it is called reflex angle, and that is the meaning of concave. One of them at least greater than 180, and that is the only difference between the concave polygon and the convex polygon. Now let's talk about the sum of measures of interior angle of any polygon. It depends on the number of triangles that divides by diagonal. Okay, to be clear, here we have a quadrilateral. Number one, we have a quadrilateral. Why? Because we have 4 sides. 1, 2, 3, 4. And here I did the diagonal. Then count how many triangles are there. As you can see here, this is number 1 and this is number 2. So we have 2 triangles. So the sum of interior angles is 2 times 180. Why 2 times 180? Because as we said at the beginning of the session, here we have the first triangle. All the angles of any triangle is 100. The sum of them, of course, is 180. So I'm gonna multiply 180 always by the number of triangles. So when we have 4 sides, here we have 4 sides, we got 2 times 180. Number 2. Count with me how many sides are there. 1, 2, 3, 4, 5. We have 5 sides. So it is a pentagon. Then how can we make the diagonal? To get the triangle, they should be separated. How? So it's not allowed to draw, for example, like this one, diagonal like that. No, I have to get separate triangles. So here we have just 3 triangles. 3 triangles. So we are going to multiply 180 always by the number of triangles. So it is 3 times 180, which is 540 degrees. Then number 3. Let's count the number of sides. 1, 2, 3, 4, 5, 6. 6 sides, so it is hexagon. Then let's draw the polygon, the diagonal, sorry. So here we have, take any vertex and draw from it, okay, the diagonals. So I got 1, 2, 3, 4 separate triangles. 4 separate triangles. So the number of triangles are 4. So 180 times 4, which is 720. Okay, what do you observe here? Let me make it with black. Okay, when I have 4 sides, I got 2 times 180. Then when we have 5 sides, we got 3 times 180. Then 6 sides and 4 times 180. Decrease by 2. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So is it a rule? Yes, of course. We can write it like that. Always the number of sides minus 2, then times 180. Now let's watch this video from AKB to be clear for everyone.
After we learn about some shapes of the polygon, how about identifying some special laws related to the polygon and its different shapes? If you are given any shape of the polygon and you are asked to identify its sides, consisting triangles, diagonals, and its interior angles, can you? Here is a quadrilateral and a heptagon inside each button for some practice. Click any of them to start. If you know that the current shape is called a quadrilateral, can you count the number of its sides with eyes? It is easy, right? You will find this quadrilateral consisting of 4 sides. But if you want to count the number of triangles that form this quadrilateral, are the eyes the right choice here to get the right number of triangles? It could be 2 or 4 triangles, but to get the right number of triangles, we have to use a law. And this law states that the number of sides minus 2 is the right way to get number of triangles that we can get using the same vertex. Therefore, 2 triangles are the correct answer here. Moreover, there is another law to easily get the number of diagonals without counting with your eyes. This law stated that any number of sides multiplied by number of sides minus 3, all divided by 2, is the right way to get the correct number of diagonals from any polygon. So, if we apply this law on 4 sides, we will get 2 diagonals, as you see in the figure. However, number of sides minus 2 multiplied by 180 is the law to get the sum of measures of the interior angles for any polygon. Hence, the sum of measures of the interior angles for quadrilateral is equal to 360 degrees. But what about the heptagon? Click the other button. Heptagon is considered another shape of the polygon shapes. If you count the number of its sides, you will find the heptagon consists of 7 sides. So if we want to get the number of its forming triangles, we are in a real need to use a special law for triangle numbers. And this law equals number of sides minus 2. Therefore, 5 triangles are the right result. Then, if we want to get the numbers of diagonals in that heptagon, we will have 14 diagonals. How did we get this result? As you may have thought, there is a law to get the number of diagonals, and this law states that the number of sides multiplied by number of sides minus 3 over 2 gives the number of diagonals. Now, we are going to calculate the sum of measures of the interior angles of the heptagon by substituting in the shown law. Hence, the number of sides minus 2 multiplied by 180 equals 900 degrees, and that result was the sum of measures of the interior angles of the heptagon.
Now we have another exercise. Okay, we are going to make comparison between the polygon, the number of sides, triangles, and the sum of measure of interior of any polygon. Number 1, for the quadrilateral, the number of sides is 4. Triangles is always subtract 2. So here I'm going to write minus 2. Always subtract 2 from the number of sides. And the sum is this triangles times 180. This number of triangles times 180. The second, pentagon. The number of sides 5 and the triangles is 3, subtract 2. Then 3 times 180 is 540. And do the same for any polygon. Hexagon, 6 sides, 4 triangles, then 4 times 180, 720. Heptagon, 7 sides, 5 triangles, so 5 times 180, which is 900. Octagon, 8 sides, then subtract 2, 6 triangles, then multiply this 6 times 180, which is 1080. Nonagon, 9 sides, 7 triangles, 7 times 180, 1260. Decagon, 10 sides, minus 2 is 8 triangles, then 8 times 180, 1440. Then for n-gon, any number. So we are going to write it n sides, then n minus 2, as I said, here it is, we have to subtract 2, n minus 2, and then multiply this n minus 2 times 180 to get the sum of the interior angles. Okay, remark. At each vertex of any polygon, the sum of the measures of the interior and exterior is always 180. So, for example, if I have this one, if I have a polygon, any polygon, okay, and here, this is called the interior angle, and this one is exterior angle. So, as you can see here, it is they are supplementary angles or straight angles. So the sum is always for the interior and the exterior is 180. Then, for a hexagon, the sum of the measure of the 6 interior and 6 exterior angles is 6 times 180. We said that right now, okay? The interior and the exterior is always 180. So the sum of them, of course, is always 180. So 6 times 180. While the sum of the measures of the interior angle is 4 times 180. Why 4? Because the hexagon has 6 sides. Where it is? Where? Here it is. So here we have 6 sides. And the interior we have to subtract 2. So 6 minus 2 is 4 times 180. Then the sum of the measures of the exterior angles is 2 times 180. How can we get it here? 6 times 180 is for the interior and exterior. Then the interior is only 4 times 180. When I subtract 6 times 180 minus 4 times 180, we get the difference between them for the exterior angles. So it is 2 times 180, which is 360. So our polygon here, the exterior is outside and the interior is inside the polygon, and the sum is 180 because they are supplementary or they are straight angles. So 180, as we said right now. Here we have another remark. The sum of the measures of the interior angles of n sides convex polygon is always n minus 2 times 180. N is for the number of sides minus 2 times 180. That is the measure of the interior angles. Second, the sum of the measures of exterior angles of inside convex polygon is always 360. So the sum of exterior angles is always 360. So number 3, the measure of each interior angle of a regular polygon is for inside n minus 2 times 180 divided by n. Here we have a new word, regular polygon. Regular polygon, it means we have equal sides and congruent angles. So we write or we draw the 5 sides or the 4 sides for the quadrilateral, or 3 sides for triangle, equal sides. So for example, for the triangle, if we have 3 equal sides, it is called equilateral triangle. So here we have 3 rules. The interior angles in minus 2 times 180. The sum of the exterior angles is 360 always. And the measure of each interior, so I'm gonna get the sum divided by n. So n minus 2 times 180 over n. Let's apply them to get more exercises on the board. Here we have an exercise about the interior angle. How many sides has a regular polygon if it is interior angle are 120 each. So if the interior angles are 120 for each one. The solution. Since the sum of the measure of the interior angles for n side polygon is n minus 2 times 180. We know that. Okay, so the interior angles, the sum is n minus 2 times 180. And here we have hexagons. So how many sides are there? For the hexagons, we have 6 sides. Therefore, the measure of each interior angle is n minus 2 times 180 divided by n. I need to get the measure of each interior angle. So I'm going to divide by n to get each one. Therefore, n minus 2 times 180 over n is 120. How do we know? Here it is given in the question, 120 each. So we need to distribute this 180 multiplied by n, then multiplied by 2. So here we have 180 times n and 180 times 2. 180n minus 2 times 180 is 360. Then multiply this n and 120. Cross multiplication or letter x. This 120 is over 1. How can we solve it now? I need to write all the n's in a side. So here we have move this 120 to the first side. So it becomes negative 120. Let me write this step. It is 180n minus 120n is equal to 360. Move this negative 360 to the other side. Okay, then I got this relationship 60n is equal to 360. Then divide both sides by 60. So the final answer is 6. So n is 6. So we have 3 rules for the sum of the interior angle for any polygon is n minus 2 times 180. Each one of them or the measure of each interior, we are going to write the same but divide by n. The exterior, the sum is always 360. So we have 3 rules. You have to focus on them. That's all about today's lesson. Thank you so much. Let me see you next time. Bye-bye.